All right, welcome back to the third episode of preparation by example. The idea here is that we're going to go through a programming exercise, both as preparation for a code interview, as well as the way that you might approach the code interview when you're actually having it. So the idea here is that it's different, at least in my opinion, than the way I'd always approached code interviews in the past. The way I've always looked at it is that I was trying to show off my skills, and that's just not really what's happening. These problems are never the sorts of things you would do in your actual job. They aren't in context. You aren't worried about libraries. You're not worried about integrations. You're not worried about performance. You're just you're trying to have a conversation with the interviewer that shows off how you think about the problems, how you think about coding. And the important thing here is that this is a conversation. It's not just you on exposition, even though this video, sort of by definition, will just be exposition. But the idea is that you're trying to engage the interviewer. It's not just that you want them to watch what you're doing, you want them to be present in what you're doing, because you want them to communicate back to the hiring manager what made you special, what made you different. And it's very hard to be different in a lot of these programming problems solely on the basis of your code. Right? Most of the time, you're going to solve the problem the way a dozen other people solve the problem. What matters is the conversation you have while you're solving it. So, I claim that there's a 4-step process that you can get in the habit of solving. Let me go ahead and bring that over into our space here. Our 4-step process is going to be create an interface. This does not mean Java interface, or if your language that you're using has a keyword interface. That's not the point. What you want to do is describe the sort of public exposure, the programming interface for the thing you're being asked to create in the interview. We'll go into more detail in just a second. But the point here is you want to very, very quickly set up what you believe you're being asked to create. The envelope, the packaging of the thing you're being asked to create. You want to do that as quickly as possible. That way when you start asking questions, or if the interviewer has comments, they're speaking directly to the code and not in some sort of like vague hypotheticals, just sort of, waving their hands in the air. They're actually talking about real concrete things in the actual file, in the actual code that you're creating. The next thing you want to do is, again, very quickly talk about how that interface you just created, how that would be used by someone else. And the way that you're going to do that is through expressing tests. Now, I don't recommend bringing in a test library. I don't recommend bringing in something like JUnit into your test environment or into your interview programming environment. And the reason for that is you want to minimize how many sort of extra things you bring in, because there's just the more moving parts, the more things that could go wrong, the more ways you might show, quite frankly, your ignorance. Not to take this personally, right? But the more things you bring in, the more different pieces you bring in, the more different things you need to be an expert in, at least for that half hour, 45 minutes, or an hour. So we want to minimize how many extra things we bring in, but we still want to be able to show how you would use the thing that you're looking at. We're always looking at it from the perspective of how would someone else use the thing we're creating. And being able to just upfront immediately put that down, it allows you to ask questions about edge cases, allows you to ask questions about performance, allows you to ask questions about all sorts of things. But again, they're concrete. There's something to speak to. The commenter can point to things, or the interviewer can point to things. You can highlight things in the code and ask specific questions that don't get lost in the shuffle. Remember, a lot of times when you're interviewing or being interviewed, especially if you're having to talk in a language that isn't necessarily your native language, or you're communicating with someone in something that isn't necessarily their native language, being able to point to the code just makes communication so much smoother. It's just in your best interest to do these two things up front. After that, you very quickly want to get into a red-green cycle. You want to make sure you have a test that fails, then you have a test that passes. Test that fails, test that passes. Test that fails, test that passes. You want to get in that habit really quickly because it gives the interviewer this feeling, gives you one as well, but it gives you the interviewer this feeling of forward progression. You're making progress on the task. And the faster you can make that loop happen, the more consistently you can sort of turn your greens into reds, or your reds into greens. The more consistently you can do that, and the faster you can do it, the more that the interviewer is getting this sort of positive feedback. Because remember, this is really important. The interviewer wants you to succeed. If you fail your interview, if you just straight up fail your interview, they feel like they wasted their time. So they want you to succeed. And the more forward progress you look like you're making during the interview, the better it's going to make them feel about spending this hour with you. It's just in everyone's best interest. I say this differently than you might have heard. A lot of times when people talk about testing, they talk about red-green refactor. Do not refactor a passing test for the sake of refactoring. You are a bad person. I try not to be this opinionated about refactoring, but I've seen it so many times. When you have something working, you're done. When you fail a test, change the code to make it easier to pass the test. That's totally cool. But once you have working software, step away. You're done. Once you have working software, you're done. Unless someone tells you to change something about the code, which happens a lot in interviewing problems. There is no reason to go touching code after it works. I will die on this hill and have many times in the past. So that's why I write red refactor green and not red green refactor. The last thing is to be clearly opinionated. They need to walk away talking about you. And it's going to just be really hard for them to be talking about your code. So what you want to make sure you do is talk about the things that matter to you and be clear. If you absolutely believe red refactor green, then absolutely stick by that. Even more during the interview than you might in the real world. Like, absolutely stand on that. If you, for whatever reason, believe that the dry principle is the greatest thing that ever happened to software, then under no circumstances shall you repeat yourself. If you think that, if you're able to pull that off in an interview, more power to you. Or in your life, more power to you. But so the point is, these are the 4 steps we're going to follow, and we're going to do this as rigorously as we can while we're preparing. So in our preparation for our interviews, we're going to follow this. But the reason we're doing this is to practice this behavior for the interview. That I would almost claim this is more important than getting your software amazing, than perfect code in your interview. Being able to have this conversation with the interviewer is absolutely going to make the difference. Whereas writing the most perfect code, I can think of exactly one. I've done hundreds of interviews. I can think of exactly one person I've interviewed where it was like, oh, I remember that code. And the only reason I remember that code is because I hated that problem and that guy made it so that I never had to ask that problem again. But we didn't hire him because we didn't hire him. Okay, so today's problem, we're going to be given an integer array that's representing the denominations of bills. So you can see down here we have 1, 2, 5. This is like saying there's a $1 bill, a $2 bill, and a $5 bill in this currency. We're then going to be given an integer representing the total amount of money. So here we're saying $11. And then we're going to say what is the fewest number of bills that can make up that amount, or -1 if it's not possible. So if the bills are 1, 2, and 5, and the amount is 11, you could return 2 5s and a 1, and that would be 3 bills. So the whole point now is, how do we figure out how to return the smallest number of bills given an amount and the bill and the denominations of the currency. Okay, that's our problem. Hopefully that's really clear. Yeah, we'll just dive into it. This test doesn't feel like it captures some of the complexity of the problem, right? In other words, it's not always true that you do the biggest currency, the biggest denomination as many times as you can, and then whatever is left over, you do the most you can with the next currency, which happens to be 0 in this case, and then the most you can do with the next currency. It's not always true that you just give the most of the biggest bills. But for right this second, maybe that's the thing we should tackle. Right? That maybe that's the right way to start this problem. So we're going to create our interface. The interface here seems pretty clear. We want to have a public. We're going to return an integer. This is going to be the number of bills. Minimum bills for denoms. This will be an int array. And an int of the amount. Okay. So this is, and in fact, we're supposed to return a -1 if we can't make the amount work with the bills. It says here we're going to return -1 if it's not possible, because 0 would be a valid answer if someone asked for $0. So that makes sense. Okay. Let's see. So the way that we're first talking about doing this, which we know is wrong, but we don't have a good example. Oh, I'm sorry. I haven't written my test yet. In case you are unaware, Java has a keyword called assert. Again, we're not going to bring JUnit into this. Java has a keyword called assert, but you have to turn it on. So that's why my default main method here reminds me to turn on EA. In other words, if I run this, it should, because it has a false here, asserting false should throw some error. It doesn't. So I have to come into my launch settings and copy and paste -EA into my new solution. There might be a faster way to do this. I would love to figure it out if I could, but for now, that is how I'm getting it. So then I come back in here, hit run. I didn't save this. You have to save the launch configurations and then run the launch configuration. Now we're getting that error. Okay. So what we want to do is assert that minimum bills, and we're going to pass it 0, 1, or I'm not 0, 1 to 5. And then also ask for $11. And our claim is that that is going to equal 3, or expected 1 plus 5 plus 5. Okay. Minimum bills doesn't exist yet, so let's go ahead and create that function. Oh, minimum bills does exist. New solution 3. There we go. New solution 3 does not exist yet. And you know what? We'll probably have enough of these going that I'm going to go ahead and have a test. So public void test. It's going to take an int array denoms, an int amount, an int expected bills, and we're going to do assert new solution 3 minimum bills. We're going to pass in denoms and amount, and we're going to ask that equals expected. Otherwise, returned result instead of expected. And then we'll just make result this guy. There we go. This is going to let us write our little tests down here a little bit faster. Let's go ahead and make this static. So what we really want here is test comma 3. Can I convert from void to Boolean? Right, we don't need this assert anymore. Assert will throw an assertion error. So errors in Java are a special kind of, well, that's not entirely true. Errors, assertion error is just an exception. It's a runtime exception, so it'll escape our main method and give us a problem. So we return -1 instead of 3, but that makes sense because we're returning -1 here. So what we're going to do is start looping over our denoms. So we're going to go for int I equals denoms dot length -1, while I is greater than or equal to 0. We're going to do I minus minus. There are obviously nice ways to iterate over these things in reverse that aren't I feel like iterating over something backwards is very complicated for folks sometimes. So that's why I'm actually writing it out by this longhand as opposed to using an iterator over this. It wouldn't be unreasonable to just reverse the array and iterate over it forwards. You will need to know that reversing an array is an order n operation, but this is already going to be an order n operation. Okay, we're going over at negative, so we want to have int remaining equals amount, int bills equals 0. We're going to return bills. Actually, what we're going to do is return remaining greater than 0, then -1, otherwise bills. There we go. All right, so while remaining is greater than denom sub I, remaining minus equals denoms sub I, bills plus plus. So again, what's happening here is we are adding up, as long as we need more money than the current bill denomination, we're going to just pop that off and increment our bills and just keep looping over that. Now, couldn't we just divide by this, like use divide and use modulus? We absolutely could. I'm cheating a tiny bit because I feel like I know the direction I want to go in solving this problem. So this while loop is obviously overkill for this way of looking at the problem. But like I said, I feel like there's some nuance that we need to try to uncover because it's possible that we can't just return the biggest bills available. So, or that this algorithm isn't really complete. We'll have to investigate that a little bit more in a second. But the point is, this should still work, even though it's got an extra loop in here instead of just a division. So let's try it. Let's see what happens. It still returned -1. Why did it return -1? Remaining equals amount. Oh, greater than or equal. That would do it. There we go. So this test passed. And the reason we know it passed is because it didn't throw our assertion error. So we computed 3 off of this, which again, this algorithm feels like it should work on 3. We looped over 5, got 2 of those, looped over 2, got none of those, looped over 1, got 1 of those, and returned 3. Okay. So let's come up with a situation where excuse me, where the right answer isn't return the most of the big one. So let's think about this. Yeah, how would you approach? Well, let's see. If I'm just thinking about it, what we want to do is make it to where the biggest currency then needs 2 ones, and the next biggest currency only needs 2. Right. So in other words, 1, 3, 4, and then asking for 6. The right way to return 6 if you have a $1 bill, a $3 bill, and a $4 bill is 2 3s, not 4 and 2 1s. But the way that this test is going to work, it's almost certainly going to return 3 because of the way we've done our loop. So we run it, and sure enough, it returned 3 instead of 2. So now we need to go change this guy to better answer the question. So here's my thought. What we want to do instead of this remaining and int bills, is say we want to have int min bills, and this is going to be originally max int. And then down here, instead of it being remaining greater than 0, it's going to be return min bills equals integer max value. Then we return -1. Otherwise, min bills is our answer. This might not be the way you want to initialize it. Maybe we initialize it to -1. Well, let's keep going and we'll figure out if maybe that's true. So my claim works something like this. Because the computer can't figure out the minimum number of these without sort of trying them all, what does it mean to try them all? So in other words, my suspicion is it works something like this. We're going to just iterate over. So instead of doing it this negative way, now we're just going to iterate over the array the normal way. So int 0, I is less than max, or less than denoms.length, I plus plus. And we want to, what we want to do is say int result equals 1 plus minimum bills denoms and amount minus denoms sub I. Let's see, but this is only if amount is greater than or equal to denoms sub I. And then min bills equals, and then if min bills is greater than result, min bills will be the new result. All right, so some folks get a little nervous about recursion. Let's talk about what's happening here. We're going to look at every denomination in our array. if the amount is more than the denomination, what we're going to say is, hey, assume the answer has one of those bills in it. What's the minimum number of bills to do the rest of the amount? Right? So in other words, we look at this, we say, okay, 1 is one of the things, cool. What's the, if we're talking about this problem, the 1, 3, 4, and 6, we're saying, hey, they asked for $6. We're going to look at the 1. We take the 1 out. What's the minimum number of ways to do 5 bills? Right? Now, the problem is we need to look at this guy and say, oh, if you're -1, we need to keep going. And honestly, it would be kind of helpful, I think, if we just kept returning max value and just did the -1 check at the very end. Does that make sense? In other words, if this was max value, it'll never be, oh, but it would wrap over. Yeah, okay. So let's do result on this guy. Whoops. So if result is greater than or equal to 0, and min bills is that. Yeah, interesting. Okay, so let's talk through this. So the point is, minimum bills takes some. It's still going to keep looking at its denominations. It's going to ask for the reduction based on returning one of these bills. It's going to get that result. If that result is positive, in other words, if it did find an answer, we want one more than that for min bills. We're only doing this greater than here, but because it's greater than, we're going to go into this thing and sort of reset it to itself if it was already one more. Right? So we don't need to add 1 to this to do the check. But there's, I feel like, an additional problem. We're doing way more work than we probably want to. And what I mean by that is, because we're going over this full set, if we take $1 out and then look at and then look at the full denomination set the next time around, it can ask all the different denominations again. So it could, in other words, 114, for this example we're doing, would be the same as 141, which is the same as 411, right? In other words, we're checking all of those every time. And so what we really want to ask is not, it's not, hey, what is the minimum bills of this new amount? It's what is the minimum bills of this new amount limited by my index. In other words, once we're asking about $1, we're never going to look at $5 or $2 or $4 or $3. We're only going to look at whatever the minimum currency is. Does that make sense? So in other words, once you start saying, well, I'm just going to count out the rest in ones, you don't stop and go, oh, well, and here's a 5. Once you decide you're in ones, you're sticking in ones. Once you decide you're not using 5s anymore, you're never going to start using 5s again. So what we're looking for now is, it's not just, we're not, in other words, this loop shouldn't go until denoms.length. It should go until whatever has been sort of the max denomination value that's been set before. So what I think we're going to do is actually change this a tiny bit. to do denoms.length amount. And then we're going to overload this guy to be denoms int denoms limit and amount. And you know what? I'm also going to just say this. I don't mind doing this in an interview. I don't mind saying the word denoms a lot. You might. That might be sort of annoying to you. Because again, you should say whatever this word is and not what you're pretending it should be. Right? So in other words, you wouldn't say int denominations, but then write denoms. So if you do want to say the word denominations, you got code complete. Just write denominations there. It's not a big deal. I don't mind doing it this way, but if you do it the way that feels right for the conversation. All right, so that's what we're trying to say is we're going to denoms limit. So once we decide we are and then the point is I isn't the denoms limit. I plus 1 is the denoms limit. So in other words, when we're talking about ones, or in this example, we're doing 1 and 3. When we're talking about the $3 bill, that's index 1, but the denoms limit needs to be 2. We're taking the first 2 denominations from the array. An important thing to ask your interviewer would be, hey, for this denoms array, is it always going to be sorted? If the answer is yes, we can do this. If the answer is no, you can throw in a sort. I don't know. Would that change? A sort might actually change the runtime, or the big O of this. Because right now, yeah, I don't know. I'd have to think about it for a while. I suspect. Yeah, I don't know. I suspect a sort isn't going to change the big O. But it's possible that, in other words, this has to be bigger than order n on denominations, because we're at least going through one loop. But because of the recursion, I wonder, I can never remember how the limit works when you are changing the upper bound of your array, of your loop index. You're changing the bounds of your loop inside of your recursion. Yeah, I can't remember. So to be honest, I'm not 100% sure that a sort wouldn't change the runtime, but I suspect it wouldn't. Because this is at least order n, and a sort is going to be n log n. So I don't think a sort is going to screw up too much. Okay, anyway, moving on. Sorry, got sidetracked. Moving on, we want we want to see if this works. Okay, we return, this is on line 43, which is the first test. So now our first test says it's not even working. So one thing I do want to make sure we do is add in if amount equals 0, return 0. So my suspicion is what's happening when amount is 0 is that it's coming through here and yeah, it's coming through here and never being able to run the if statement. So it finishes this loop and then says, hey, I can't return 0. So my suspicion is we need to handle 0 special by just returning 0. Let's see how that works. And sure enough, that was it. All right. Now, is this the fastest way? Couldn't tell you. Is this the way that you should solve it? Like, in other words, is this sort of like the ideal solution for this? I honestly am not sure. But I do think this answers the problem. I do think it solves what we were given. We detected a weird edge case. We addressed that weird edge case and showed that we addressed it, right? And by weird edge case, I mean when we want to return 2 3s instead of a 4 and 2 1s, right? So we uncovered some of the nuance of the problem. We handled the nuance of the problem. We did it in a way that, honestly, this isn't my kind of method, but in all fairness, it's fine. Like, this isn't normally the way I would write code, but that's because normally the way you would write code, you would never care about the number in any real context, right? Like, how many bills should this be? 3. Cool. Which 3? And to be honest, I think solving that problem would have been even more fun than this problem. So, anyway, there you go. That is the problem here. Again, I wrote it in the code here, but I didn't say it as part of the audio for this this particular thing. This is adapted from LeetCode. I don't want to take anything away from them. They are fantastic in what they do and the service they provide. The problem is called coin change, and the URL will be, it's both here on screen and it'll be in the description of this video. So again, thanks for joining me on this. Hope this was helpful. Please feel free to leave any comments on how I can improve this for you and make this a better resource going forward. Thanks again.